Hi and good day to our lecturer, Mr. Koh Hai Moon. Today, we would like to present our group project proposal, which is Post-Tension Double T-Beam Pedestrian Bridge. Our group members consist of 5, which is me, Muhammad Razwali bin Muhammad Zaid, Aimin Syuhada binti Zulkifli, Mariatul Shazuni binti Muhammad Kamal, Siti Hariza binti Makma, and last is Muhammad Hazim Nasrullah bin Muhammad Idrus. We are from section 1. Company Our company's name is Mega Engineer Consulting Company, which is led by me as a project director. And we have one designer, which is Mariatul Shazwani. And then we have civil and structural engineer, which is led by Aimin Syuhada binti Zulkifli, Siti Harizam bin Mama, and Muhammad Hazim Nasrullah bin Muhammad Idrus.
For the project details, the objective of project is to build a pedestrian bridge to cross over the Jalan Keluang for the safety purpose of UTHM students. The location is in front of UTHM main campus beside Jalan Keluang Paliraja. The types of bridge is T-beam bridge. T-beam bridge is a structural element that able to withstand large loads by resistance in the beam or by internal reinforcement. T-beam bridge constructed by precast. T-beam bridge is popular for short spans and economical. Material used for pre-stressed concrete T-beam is high-strength concrete. Second is screed-cage of concrete, and third one is high-tensile steel.
Next, I will explain about the architectural drawing for post-tensioning double T-beam pedestrian bridge. This is our bridge elevation view. And then we have the front view of the double T-beam. And then they have the top view where we can see the width and length of the pedestrian road. And then we have the side elevation view of the bridge, which is the full, where we can see the rail guide and the stairs of the bridge. And last but not least is the detailing of the stairs, guardrail detailing, and roofing detailing. So this architectural drawing can be find out in our report in section of architectural drawing.
For the structural system, a pedestrian bridge structure is divided into parts. First is superstructure that offer horizontal spans like decks and girders and directly carries traffic loads. Second is substructure that supports the horizontal spans which rise above the ground. For the elements on pedestrian bridge, first is decking, consistent of deck slab, girders and trusses. Bearing for the decking, abutments and piers, foundation for the abutment and piers, river turning works, approaches to the bridge to connect the bridge, handrails, parapets and guard stones.
Assalamualaikum and good morning. My name is Aimshara binti Zulkifli and I will present for the properties used in design. Our project title is Proposed Pedestrian Bridge to cross over Jalan Keluang beside the UTHM main campus. And the code of practice used in this project is Euro Code 0, Basic Structural Design, Euro Code 1, Action on Structure, Euro Code 2, Design of Concrete Structure, British Standard 5400, Code of Practice for the Design and Construction of Steel, Concrete and Composite Bridge, and the Euro Code 2. This is the concrete and steel properties. Concrete grade we use is C45. Compressive strength is 40 Newton per millimeter square. Mean compressive strength is 48 Newton per millimeter square. And the type and size of steel used is T20. And the steel characteristic yield strength is 500 Newton per millimeter square. And this is the bridge description. The height of the bridge is 4,500 millimeter and the width is 3,000 millimeter. The span length is 23,000 millimeter. Number of T-beam used is 2 and number of pier is 2. The slab concrete thickness is 200 millimeter. This is the tendon properties. The width of T-beam is 3,000 millimeter. The height of T-beam is 1,350 millimeter and the length is 2,000 millimeter. The tendon type used is 7-wire low relaxation height range and the nominal size is 15.7 millimeter. The young modulus is 195 kilonewton per millimeter square. And the T-beam description is double T-beam post-tension bridge. This is the guardrail detailing. The length of the rail is 2,200 millimeter and the width is 1,300 millimeter. And for the governance tube size is size C. The stud detailing is rise is 2,250 millimeter and the length is 6,100 millimeter. For the roof detailing, the height of roof is 2,800 millimeter and the width is 3,000 millimeter. The roof type is aluminium zinc roofing. Structural system used in this project is the superstructure is deck slab with longitudinal girders and cross girders, and the substructure is piers, abutments, and foundation.
Hi, I am Mariatul Shazwani and I would like to explain about the details analysis for our project. So for our project, we use the double T-beam for the pedestrian bridge, and this is our section properties. First of all, we calculate the total dead load, and we got 1,850.72 kilonewton meter. This is our allowable stress. For the F prime max, we choose 20 Newton per millimeter squared, and for the F max, we choose 16.50 Newton per millimeter squared. For the F prime min, -1 Newton per millimeter squared, and for F min is 0 Newton per millimeter squared. Next, we determine the ZT and ZB value. So for the ZT proposed, we got 0.0976 meter cube, which is greater than ZT allowable, 0.0351 meter cube. Therefore, the section for ZT is acceptable. For the ZB proposed is 0.0445 meter cube, which is greater than ZB allowable, 0.0343 meter cube. Therefore, for the section size is acceptable. Next, we determine the minimum cover and also the maximum E. And we got the E is 503.292 millimeter. Therefore, maximum E is 503.3 millimeter. From the Magna diagram, we estimate the pre-stress force. So for the highest point, the minimum pre-stress force is 1,060.6 kilonewton, and for the lowest point, 20,408.16 kilonewton. Next, we go to the cable zone and profile. The limits for the cable zone is given by the inequalities 9.6a until 9.6t. So this is we got for the inequalities. And for the distance, which is 0, 2.5 meter, 7.5 meter, and also 13.5 meter. And for the cable profile, if the shape of the chosen cable profile is parabolic, then if the eccentricity at midspan is 112 millimeter and at the support is 0, giving a uniform stress at this point, the shape of the profile is given by y equal to 4 times 0.112 divided by 23, the power of 2, times 23 minus x. Okay, for the number of tendons, the proposed number of strand n equals to 36, which is symmetrical, 6 in each web. And for the stress in strain, 1,211.2 Newton per millimeter squared. And for the design stress is 1,234.3 Newton per millimeter squared. And we do the checking, which is we got okay for the checking because the stress in strain is less than design the stress. So we provide the 36 North 7 wire 15.2 millimeter diameter standard strand, which is with spacing between the tendon is 50 millimeter.
For our analysis and design details, for the part of loss of stress in terms of short term, we have found that the losses in elastic shortening is 5.1%, and for the friction is at midspan is 4.07%, and at support is 7.98%. For the anchorage roll-in, the loss of stress at the left end is 598.45 kilonewton. For the pre-stress force at left end is 5,794.41 kilonewton, and for the midspan is about 6,000, and at the right end is 5,862.04 kilonewton, and last but not least, the pre-stress force after losses, which is the 5,900 kilonewton. For the ultimate moment resistance, we have found that it is 15,189.13 kilonewton meter, and for the ultimate shear strength is 257.70 kilonewton. And this is the design summary for the hour and block design, which is the vertical bursting tension. We propose for the 4 H legs of T12 with spacing of 100 mm. At distance from the loaded face is 800 mm. And for the horizontal bursting tension, which is 2H legs of T12 and T16, both of the spacing is 100 mm and the distance is 130 mm. For the surface falling tension, proposed reinforcement required is T8 with a spacing of 100 mm, where the distance is next to the loaded face. And for the deflection of short term at transfer, we have calculated with negative 0.034 meter, and for the at service, negative 0.00247 meter. And for the long term deflection, we have found that it is okay with 0.084 meter is less than 0.0096 meter. For the calculation part of the ultimate moment resistance, ultimate shear strength, the stress block design, deflection can be referred to our report in section of analysis and design details. Thank you.
Hello, Assalamualaikum warahmatullahi wabarakatuh. So for the detailing, for the main beam is we use six tendon to layer in a beam in a double in a T. So with width 76 millimeter. So for the railing detail, we have a length for uh, the steel is 800, so we use the steel T12 at the outside, and in the tendon we use steel T16. So the dimension for the tendon is 65 multiple 65. So for the double T beam, we have a beam is 2400 millimeter. So for the length for the T is 133.85 millimeter. So the tendon for the length tendon is 50, width 50. That's all from me. Thank you.
In conclusion, the purpose of this project is to build a pedestrian bridge to cross over the Jalan Keluang for the safety purpose of EDHM students. The type of beam proposed for the bridge is a T-beam bridge. The design was produced in adherence to the provision of relevant codes of practice and with regards to previous works. The T-beam bridge will be constructed by a precast bridge, which is popular for short spans, economical, and safety throughout the service life of the bridge. This study, therefore, can be used for the construction of pedestrian bridge anywhere in the world with modification at the foundation level. That's all for me. Thank you.